Right, so continue now. If we have stress, we must have strain. Right, so if you were to look at a pressure vessel, let's have a slice of it or a piece of it, we know that we have sigma hoop being applied in that direction. Right, so sigma hoop tends to, as I said before, increase or decrease diameter. So therefore, we would have some hoop strain that is associated with it, and that will be the change in diameter over the original diameter. Right, so if we go back now to Hooke's law, we could recall that this on the side we had like epsilon x was 1 on E sigma x minus mu sigma y, right? This was in the Cartesian coordinates or x and y coordinates. In case of hoop and radial and longitudinal, we could have, let's replace the x and the y with, because remember we had hoop and longitudinal, right? So if we were to plug in now our values or equations now, this was PD on 2T, PD on 4T. We could simplify this and end up with PD on 4ET. Right, so it's just algebra at this point. Right, that is mu, or Poisson's ratio. We know that epsilon h is also that. So we could say is equal to, right, so we could actually determine now the change in diameter of a pressure vessel, which is PD squared on, right? So there's no need to memorize these formulas, you could just derive it when you need it to be. Right, so we can also show that the change in length right, so these are our two terms associated with the change in the dimension of the pressure vessel.